Obesity is often discussed in terms of lifestyle choices and external risk factors, but beneath the surface lies a far more intricate and unsettling reality: the disruption of cellular machinery that can turn excess nutrients into malignant fuel. At the core of this biological cascade is a powerful regulator called mechanistic target of rapamycin, mTOR, a nutrient-sensing kinase that governs cell growth, metabolism, and survival. In the context of obesity, mTOR signaling becomes chronically overactivated, pushing cells toward unchecked proliferation and impaired self-cleaning processes. This dysregulation is no small detail. It is a central mechanism by which obesity drives cancer development, progression, and resistance to therapy. Under normal conditions, mTOR acts as a finely tuned metabolic switch, responding to the availability of nutrients, energy, and growth factors. When functioning properly, it coordinates when cells grow and divide, when they pause to repair damage, and when they break down faulty components through autophagy, a critical recycling system that helps prevent disease. But obesity upends this balance. Constant overnutrition, particularly from high-fat and high-sugar diets, leads to persistently elevated insulin, glucose, and amino acid levels, all of which hyperactivate the mTOR pathway. This chronic stimulation creates an environment in which cells are pushed to grow faster, live longer, and bypass important checkpoints meant to prevent malignant transformation. One of the most troubling consequences of mTOR overactivation is its suppression of autophagy. In healthy tissues, autophagy serves as a tumor suppressor, clearing damaged mitochondria, misfolded proteins, and other cellular debris that can otherwise accumulate and contribute to genomic instability. But when mTOR is chronically active, as it often is in obesity, autophagy is suppressed and toxic cellular waste builds up. This dysfunction makes cells more vulnerable to mutations and metabolic stress, setting the stage for tumor initiation. In parallel, the mTOR pathway directly enhances the translation of proteins involved in cell cycle progression, angiogenesis, and survival, all of which support tumor growth. In essence, obesity doesn't just make cancer more likely by increasing systemic inflammation or altering hormone levels. It actively rewires cells to be more proliferative and less able to self-correct. This is not a slow, indirect process. It is a potent and immediate driver of oncogenesis at the molecular level. The connection between mTOR and cancer is not merely theoretical. In many obesity-associated cancers, including breast, liver, colorectal, kidney, and endometrial tumors, elevated mTOR signaling has been observed both in precancerous lesions and in aggressive tumors. These cancers often display poor prognosis, not only due to their biology but because they resist conventional therapies. The metabolic adaptations driven by mTOR make cancer cells more resilient to stress, including chemotherapy and radiation. In fact, several studies suggest that tumors arising in the context of obesity may be less responsive to treatment precisely because of their altered signaling landscapes. Moreover, obesity impairs the body's broader nutrient-sensing system by interfering with regulators like AMPK, which normally inhibits mTOR during low-energy states, and insulin/IGF-1 signaling. These pathways are intricately interconnected. When energy sensing fails, cells lose their ability to regulate growth based on real need, leading to what can be described as metabolic anarchy. The body, flooded with signals for growth, inflammation, and nutrient abundance, becomes a fertile ground for neoplastic transformation. Recent research also highlights the interplay between mTOR and immune regulation, another cancer-relevant domain disrupted by obesity. Elevated mTOR activity in immune cells can suppress anti-tumor immunity, reducing the activity of cytotoxic T cells and increasing immunosuppressive regulatory T cells. This not only accelerates tumor growth, but also hampers the efficacy of emerging immunotherapies. In obese individuals, the very pathway that drives metabolic dysfunction may simultaneously dampen the immune system's ability to recognize and destroy cancer cells. This molecular understanding should serve as a wake-up call. Obesity is not just a lifestyle issue or a passive risk factor. It is a condition that rewires the biology of cells in ways that actively promote cancer. The persistent activation of mTOR is emblematic of this transformation, bridging the gap between external dietary excess and internal cellular chaos. And yet, despite the mounting evidence, This mechanism is rarely highlighted in public health messaging or even in many clinical cancer prevention strategies. Neglecting the mTOR link in obesity means missing a crucial opportunity to intervene early. Drugs that modulate mTOR activity, such as rapamycin and its analogs, are being studied for their potential in cancer prevention and treatment, especially in metabolically compromised patients. Lifestyle interventions that restore metabolic flexibility, like caloric restriction, time-restricted eating, or physical activity, can also normalize mTOR signaling and potentially reverse preneoplastic cellular changes. But these strategies must be framed within the context of biology, not blame. People need to understand that obesity changes their cells, not just their appearance, and that these changes can be targeted and reversed, but only if acknowledged. As cancer incidence rises globally alongside obesity, ignoring the molecular connections like mTOR is no longer an option. These are not abstract pathways. They are real-time signals driving tumors in millions of people. If we are serious about preventing cancer in the 21st century, we must look beyond calories and body mass index and toward the disrupted cellular machinery that makes tumors possible. The mTOR connection is not just a piece of the puzzle, it is a central thread tying together nutrition, metabolism, immunity, and malignancy. And it deserves far greater attention than it currently receives.